All right, Ms. Wilson, as you were saying, now back to the question. So this is where we are at with the diagram. And you were asking a question in relation to the right angle triangle. So go ahead and ask the questions.
Yes, sir. I would say we form the right angle, sir, where the dotted lines are. We know that.
Ms. Wilson, go back
Yes, sir.
and start again, because in the start of it,
are you hearing?
Yeah, man, I'm hearing you, but you're cracking up sometimes. So go again.
Yes, sir. I'm saying where we started the right angle triangle, sir, with the dotted lines. Now I was looking at from the north line, sir, to where it was formed, that we would discover a right angle triangle.
Hold on, Ms. Wilson. So let me identify where you're talking. So you're saying that
from the north line coming down, sir, to running across P, that we would form a right angle, sir.
So we have this north line from P.
Yes, right? Yeah, so that
coming all the way down to down here.
Yes, sir, would form a right angle.
Yes, that is correct.
So I'm saying, sir, would it be safe to just call the whole angle right there 90, or would we just put in the 20, sir, for the unknown at the little part of P angle there? So
no,
because we know it only took 20 more to make the complete 90.
You're asking if you could call it. Give me a second, Miss Wilson. No, I'm not see any text on her yet. I have to go check. I'm in one class now, so I can't talk to you. All right. All right, Miss Wilson.
Yes, sir.
Yes, sorry about that interruption, guys. So, go ahead and explain what you were saying just now.
Yes, sir. I was asking if it would be safe to just rename the entire angle as 90, or would we just fill in the little unknown down here as 20? As we know, it would only take 20 more to be added to make the complete right angle of 90.
All right, so we know that this actually would be 20.
Yeah.
Right. But the question is, would that be the angle for the right angle triangle that we have constructed?
No, sir. We still need one little piece.
Right. So the key thing then, we have to determine what that 90 degree, that angle would be, that acute angle. So we have to get the exact calculation for that angle.
A little piece in this too.
Right. So clearly, we would have a challenge in calculating that little part there. So what else can we do? Do you think we can construct any more right angle triangle that could help us?
Yeah, sir. Yes, yeah, sir. We see what we can do. From where the 40 degrees angle is, right? We can, yes, sir. We can make one right there, so. And would have and then we could yes, sir. Just rename the little the part this one.
Okay. So you would,
and then we could use the sine rule.
Well, not sine rule, but sine ratio.
The sine ratio.
Right. So we need to label these points. Right. We can label these points. So in the interest of the labeling, let me just put that down there. All right. So we could also do that for up there too as well. And we label these points.
Oh, so you call that one C, sir?
We are labeling these points just to give you a point of reference, all right?
Mm-hmm.
All right, now, so there we are now, Miss Gleason.
Yes, and I was saying we could use the sine ratio.
All
which
right.
is opposite over hypotenuse.
All right, so the thing is what you're really trying to find in terms of using the sine ratio. Because remember, if you're using the sine ratio, remember if you're using this as the hypotenuse, then which other side would include the sine ratio?
The AC, sir.
All right, so you're trying to find this side. How would this side help?
Sir.
How would this side help you?
Why?
If we call this X, or finding X here. Is there any other relationship you can make with X?
Checking, sir. With the same right angle triangle, sir? With the same triangle where?
With the entire diagram.
Oh. Yeah, yes, sir.
All right.
No,
what,
sir.
What
on this one? Is it no, sir? Because we're trying to find this little one here. Only that when we discover AC, sir, it'll discover DF as well. We go find the amount for DF because them would have basically be the same.
All right. So if you know DF now, at least you don't know a little part of the height.
Yeah.
Of the right angle triangle. All right. So let us go through the process as I will say. So if you use the sine ratio for this triangle, you would say sine 20. Equal to what?
X over 8, sir.
All right, so X over 8.
And
you want to find X. So what you do?
We're gonna bring the 8 to multiply by the sine 20, sir.
All right, so
equal to X.
So 8 sine 20.
And then sine 20 would be 0.342.
Let me see if I can really draw this thing, guys, because this thing is really making. All right, so 8 sine 20.
Yes, sir, it will be 0.382. Oh, equal X. And then
X then would be equal to
8 times 0.342, sir.
0. 0.342.
Yes, sir.
And what
which
you
is
get?
2.736. We'd round it off to what? The 2 decimal, please. So it will be 2.74.
Before you do any rounding off yet, just because you're just doing one side to the one leg of the right angle triangle for the big right angle triangle.
Yes,
so
sir.
give me this value,
2.736. That's where it stops.
736. All right. So don't round off yet. So we would have known that this part of the height would be 2.736.
As well as DF.
it's a 2.736, right?
Yes, sir.
All right, go ahead then. So if you're following that step, what else can we do now?
So we will work out BD now? Because since we basically can use the same sign ratio for that part as well.
All right, so you must apply your reasoning. You know, why would you want to work out BD? And remember, your aim is to find
because the thing is, sir,
right? That's what you're going after.
Yes. So when we find the whole length, then we would have that to work with, and then.
All right, go ahead then. So you're doing BD.
Yes, sir.
So let's give that a label. Let's call that Y. So we can use the sign of what?
Ratio.
What angle?
Sign of 50 degree. Sign of angle A, 50 degrees, sir.
I'm not getting any response from anybody else. What is happening, guys? Don't have any input? Have to all work together. Yeah. All right, so that would be equal to what, Ms. Lisa?
Sine 50, sir, is 0.766.
Oh, in terms of the ratio.
Huh? X over 5, sir. X over 5.
All right, so remember now we had to use X down here. We don't want to use X up here, so we're using Y.
Oh, okay,
so we
sir.
have Y over 5.
Okay.
So, and the reason for that, to put X up here, what we would be saying, whatever we calculate here should be the same.
Would be the same as X.
So, yeah, so we cannot use the same variable to represent two different values, all right?
Yes, sir.
All right, so next we would have then, based on what we did before, we would have 5 sine
50.
5 sine
equal to Y.
So Y then would be equal to Y.
5 times 0.766, which is equal to 3.83, sir.
So 5 times
0.766.
766.
766, sir, you have an 8 there.
5 times 0.766. All right, 766. All right, so with that calculation, what you get Y to be?
3.83, sir.
All right. All right, what next can we do? So we know this is 3 points.
We can add the 2.736 plus the 3.83 to get the full length from F to B to F, sir.
All right, so we could do that. And what would be that full length? So I'm going to use a different color for the full length. So if you add
3.566, sir.
So the length from B to F.
Yes, sir.
So BF
would be 6.566.
6.566. All right, go ahead, continue.
Yeah, sir.
Do we need anything else to help us? All right, so we have the height of that big right angle triangle, but we still don't have any angle within that big right angle triangle. Can we find the base of that big right angle triangle in a similar way as you just did, Ms. Wilson?
Oh. The base, sir.
And why would we want to find the base? Because remember now, if you have two sides of a right angle triangle, you can always calculate the first side.
Base. Oh, we don't have the measurement for the
No,
we don't have the hypotenuse, sir.
You still have those two smaller right angle triangles that you use to calculate the height. You can use them also.
Which?
All right, going back to this first right angle triangle with the 20 degrees. How can we find this side P to C? How can we find this side using that same triangle? And let us call this length Z. How can
we do the adjacent over the hypotenuse?
Exactly, so we could do that. So we could, if we use adjacent over hypotenuse, what ratio are we using?
Co-ratio, cost ratio.
All right, so we're using the cost ratio then. So cos of
20 degrees.
All right, cos of 20 degrees. I really hate writing with this thing. So cos of 20 degrees.
Equal to?
Equal to?
X over 8, sir.
Remember, we are using a different variable. Not using
we
are using Z over 8. All right. I generally put a little cross in the middle of my Z because my Z's are usually resembling 2. All right. Okay, all right. So here now, if we are making Z the subject, we could have what? 8 cos.
8 times cos 20, sir.
All right.
Equal to Z.
So Z would be equal to what?
0.939 times 8, sir.
0.939. And so Z would be equal to what?
7.512, sir.
All right. I want to hear from somebody else in the class. Give me the answer, Miss Wilson.
7.512, sir.
7.512. Guys, this class is not only for Miss Wilson alone, it's for all of you to participate. So I hope you guys are paying attention. You can give some input to as well. Can somebody else work out the side from C to F for us, apart from Ms. Wilson? Will you be able to assist us with that, Mr. Lamar? So let me label C to F. I'm going to label that W. Mr. Lamar?
Yes, sir.
Could you add some support?
Sir. Sir?
Yeah, I'm hearing you.
Sir, I have to realize, sir, I have to look one because I was not paying attention.
You see, that's a problem. I mean, if we are here going to the question and you're not paying attention, it's not benefiting you at all. So you have to now look at what has been done and see how you can find that length of W for us. Ms. Wasom, can you give him an idea what you were doing with the first triangle so that he would be able to apply it?
Repeat, sir.
Could you assist Mr. Lamar in how to solve for the other side? Just
so wait a minute.
Just point out the ratio to him if he's not able to see.
For this one that he'll be working, sir?
Yes, that will be CF.
Well, sir, I was thinking he would have to find AD first, sir. And right. Then AD would have corresponded with CF.
Exactly. So we could write W at AD too as well.
Yes, sir.
Mr. Lamar, can you go from there?
Man, we're good.
Ms. Green, are you following so far? Are you understanding Mr. Arti and Ms. Green?
Yes, sir. So the only problem I don't have the calculators yet to do the work, you know.
Yeah, but you can offer your support. You can make suggestions as how to go about doing it. We cannot just sit and just allow one person to do all the work and everybody else sit and just watch. All right, guys, that's not how we work. We have to work in groups to get the work done. All right, so go ahead, Mr. Lamar. Have you come up with some way how you can calculate W?
Should I try calculating using X on the?
No, you wouldn't be able to use X because X is not a part of that right angle triangle, that small right angle triangle up there.
So you try to find CF.
CF, right. But whereas Ms. Wasom said that AD is the same length as CF. So if you are able to find this length, you would find
you would be able,
right? Because that length is the same as CF. So what can you do to calculate that length? Mr. Lamar, this length, what can you do to calculate this length?
Sir, no. Sir, you have it 50 degrees right there, so. So you can use, if you try to find out, you'd have you're using. No, okay.
Say what you were saying just now, Mr. Lamar. Can we use a trig ratio here? And what would be that ratio?
So we're trying to find W.
Right.
So I'm gonna use angle A.
Right. And what is the angle at A for that 50 right
degrees.
Angle? All right. So which ratio? What are the sides? You know some sides, and you are to find W. What can you do? bearing in mind, this hypotenuse is 5 kilometers.
Yes, sir.
This side, which is BD, is 3.83 kilometers. You also have, so you have the hypotenuse, you have the opposite side.
Also, so if we have the opposite side and we have the hypotenuse, we don't need fusion, we don't really need fusion integration. We can just use Pythagoras theorem, no?
Exactly, you can use Pythagoras theorem, but I'm going to ask for your sake to use the trig ratio.
Okay, sir. Sure, so we have hypotenuse and opposite.
And basically we're trying to find the adjacent. So if we can use hypotenuse with adjacent.
It's our opposite with adjacent.
Our opposite with adjacent.
Exactly, yes, sir. So I was thinking about the tangent rule.
Tan ratio.
Yes, sir.
All right. Why not use the cos ratio as Miss Wilson has been doing?
So it make one difference?
Well, in the sense that if you see, y would have already have some decimals, and I don't want.
All right, so okay, sir. Then we use the cosine ratio.
All right, so the cosine ratio, that would give you what? Cos of what?
Cos of 50 degrees.
And that would be equal to?
So AD,
right.
RW, W over.
So we'll label that W.
Over 5.
Over 5, all right.
So then you don't want.
So we want to find
5 as a subject.
All right, so we say 5.
RW as a subject, W as a subject.
All right, so we would bring over the 5 and times the cos, right?
Yes, sir.
So 5 cos 50. Is equal to W.
Sure.
Oops, sorry. So what is W here?
Sir, cos 50 is 0.643.
All right, let me write the 5 first. So we have 5 times
0.643.
643. All right, and when you make that calculation, what W equals to?
3.214. 3.214.
4. All right. All right, so now we would find the length of W. Miss Wilson would have already found the length of Z. So we know Z is 7.512. And W now is 3. What was that? 214?
Yes, sir.
Okay. All right. So here we have the lengths down here. Can we sum these two now to get the length of the base? So the length of the base would be P from P to F.
Yes, sir.
So what would that be equal to?
So you'd add the 7.512.
And what again?
Sir, Seven point.
So that's 10.726.
10.726. 726. You got that to Mr. Lamar?
Yes, sir.
Okay. All right, so here we are now with the bigger right angle triangle, we know the height of BF, which is 6.56. Now we know the length of the base, which is 10.726. Do we know any angle within the big right angle triangle? Do we know any of the acute angles? Meaning, do we know
20 degrees?
No, do we know this angle? Or do we know this angle? Miss Green, do we know any of those angles?
Sir, I don't know what you're talking about.
That means you're not following, you're not paying attention. We are referring to this big right angle triangle, Miss Green. Pay attention, please. I know it's a long question. So this is the big right angle triangle that we're referring to. And I'm asking you, do we know the two angles that are highlighted in red? Do we actually know any values for those? Ms. Green, waiting on your answer.
Yes, sir, you know one of them.
What you know?
Sir, the one with the sir said 20.
Is that 20 degrees for the big right angle triangle or for the smaller right angle triangle?
Smaller right angle triangle. That would be small, sir.
Right. So it means that we wouldn't really know the angle in the big right angle triangle then. You agree, Miss Green? What about you, Mr. Artie? Do you agree?
Sorry, we don't know the angle for the big right angle triangle, but we know for this small angle.
All right, so it's a right angle triangle and we know two of the sides. We calculate the length of the base by adding the sum of PC with CF. We know the height by adding the length of DF with BD. And so do we really need any angle within that big right angle triangle to calculate PB? Do we need any angle, Miss?
Sure. Sure.
Mr. Lamar, go ahead.
So at this point, we can't just use Pythagoras theorem and just find the hypotenuse.
Because we don't need any angle to calculate PB, so we can use Pythagoras theorem. All right, is everybody following and understanding so far what is the aim of this question? I'm going to clear all that we have done here. And I'm just going to walk you back through what we have been doing. All right. So what we know is that the question asks us for the length of PB, which is a distance that the boat would be from B. And it also wants you to calculate the bearings that the boat would be. Now the bearings would have to be from the north line to the line of PB. So we also have that to calculate, guys. All right, so we have not done that calculation yet for the bearing, but we have been working on the calculation for the length of PB. So we know that we need to calculate, oops, I really don't like this thing. All right, so let's call that is theta, which is the bearings, right? And remember now, this is not 70 degrees. The 70 degrees come all the way down here. All right, so PB now is what we want, but we know this length, which is PF, and we know this length. And Mr. Lamar would have suggested that we can now use Pythagoras' theorem, which is correct. All right. So it means that calculating these lengths that you would have already done. All right, and when we sum the lengths, we would get these for PF and BF. So if we're applying Pythagoras' theorem now, we would have PF squared plus BF squared would be equal to that. And then now we would